Hello, college algebra fans. Continuing on with the ginormous section 4.3, properties of logarithms. We've gone over these in class. Do you remember them? Do you remember how I was telling you how to memorize this by thinking of the logarithm as a kind of corrosive acid that you pour on these bonds here, multiplication, division, exponentiating, and it kind of dissolves them into weaker operations. So for example, the log base b of a product x times y is just the sum of the log base b of x plus the log base b of y. The log base b of division looks almost exactly like that, just has subtraction going on between those two. And the big win, the log base b of an exponential expression, which was really hard to calculate by hand, is much easier now. It's just n times the log base b of x. So that n just kind of floats out front. That's why we call this the magic property of logarithms, because they undo exponential expressions. Makes sense, right? Since logarithms are inverse functions of exponentials. So using those properties, you're asked to do a number of things. For example, can you expand the expression log base b of this quotient, m times n times q, all divided by p cubed? Well, using the properties of logarithms, you could say this, the main operation here is that this numerator is getting divided by this denominator. So this is the log base b of the numerator, m times n times q, minus the log base b of p cubed. One thing at a time. We can see that we still have more to do. When they want you to expand a logarithmic expression, they want you to keep expanding it until you can't expand it any further, just like the word simplify. So let's see, this is the log base b of what? Well, we've got product of three things here. So we really have that the log base b of m plus the log base b of n plus the log base b of q, all that, well, being subtracted from it is minus the log base b of p cubed. We could keep simplifying that too. So let's back this up a little bit. Now, do we need to carry these brackets around? No. We could write this as the log base b of m plus the log base b of n plus the log base b of q minus this log base b, but that p cubed, that 3 can come out in front of it. So minus 3 times the log base b of p. Now they are simplified as much as they possibly, expanded as much as they possibly can. There's nothing else to do. Now don't recompile it. That's not what you're asked to do. You're asked to expand it, not contract it. That's the next set of exercises. How about this one? This one logarithm can be rewritten as a combination of simple logarithmic expressions. That's what they might have said here instead of the word expand. Okay, or here. So we're taking the log base b of this big thing, which is a radical. And we remember that the radical of anything is the same thing as that thing raised to the 1/2 power, right? So let's first rewrite this as the log base b of this quantity x cubed over z to the m being raised to the 1/2 power. So working from the outside in with our corrosive acid of this logarithm, we're going to put that exponent, have it float out front. 1/2 times the logarithm base b of x cubed over z to the m. Okay, all right, so 1/2 gets multiplied by everything that happens inside there, so don't forget that. Now we have log base b of a quotient, just like we had up here. We can do that. Log base b of the numerator, x cubed, minus log base b of z to the m, the denominator. There's that. And we keep this whole expression inside brackets. The whole thing gets multiplied by a half. Now we can bring this 3 out front. So we've got 3 times the log base b of x minus, that m can float out front, m times the log base b of z. So if they want to have no parentheses left, you could distribute that 1/2. So we're left with 3/2 log base b of x minus m over 2 log base b of z. Of course, they want you to be able to do it the other way around as well. So if you're given a bunch of small logarithmic expressions, can you combine them or contract them into just one logarithmic expression? When you see a sum of logs, you should think you're taking a product. So you're actually taking a log of a product, I mean. So that would be x plus 2 being multiplied by x, minus still the log base 3 of 5. Okay. So now what's going on? We have the difference of 2 logs. Oh, well that means we were taking the log base 3. These are all log base. They have to be the same log base, same base of the logs for us to be able to combine them like this. So as long as that's a 3 and that's a 3, we could say, oh, well, this is just the log of a division. It had an x plus 2 multiplied by an x in the numerator, and it must have had a 5 in the denominator. So now we are down to a single logarithmic expression. Nothing floating out front, no coefficients. That's what they wanted. Maybe they would write this as the log base 3 of multiplying that variable through there, x squared plus 2x, all divided by 5. How about this one? Now we have lots of little coefficients up front, here and here. So what we can do is swing those up here, and they are powers of the argument of the log base b. All right? So this would become log base b of m to the 1/2, also known as the square root of m, plus 3/2. Log base b, this 3/2 is going to become a power on the whole argument, 2n raised to the 3/2. We still have this minus log base b of m squared n. Should we split that up? No, we're supposed to be contracting, right? So let's see. Well, we got a sum of logs. Let's multiply those. In other words, we're taking the log base b, putting the sum of logs into the log of a product. That looks like m to the 1/2 multiplied by 2n raised to the 3/2 minus the log base b of m squared n. Difference of logs can be rewritten as the log of a quotient. So what's in the numerator? M to the 1/2, 2n raised to the 3/2. What's in the denominator? M squared and n. Can you simplify them? Then you should. As long as you keep one big log, that's what they're asking for. So let's see. M to the 1/2 divided by m squared. A quotient of exponential expressions with the same base means we subtract the exponents. What's 1/2 minus 2 whole? 1/2 minus 4/2 is negative 3/2. So this is the log base b of m to the minus 3/2. And what do we have here? 2 raised to the 3/2 times n to the 3/2 divided by n to the first power. So this can simplify. 3/2 minus 1 is just 1/2. This 2 to the 3/2, nothing we can do with that. Just write it as 2 to the 3/2. And again, 3/2 minus 2/2 is 1/2. So that's n to the 1/2 there. Now this possibly could be cleaned up. See, they're both raised to the 3/2. and that's a negative one. So we could write this as the log base b. If they don't want to have any negative exponents in there, they might want you to write this as log base b of 2 over m, the whole thing raised to the 3 halves, times n to the 1/2.